Hello friends, welcome to part 4 of Solve Paper Classical Dynamics 2021 5th semester Dibrugarh University, and we have already solved up to question number 4b, right, in the last video. Okay, so I have already made 3 parts. Okay, and the playlist gonna be appearing at the end of this video, right? And before we start, please subscribe the channel, hit the thumbs up button, also share with your friends for me to create new contents for you. And today in this video we're gonna start from question number 4c. And if you want to follow me on Insta, this is my Insta ID, Oza Loikajit, OJHALAKHYAJIT 123. This is my Insta ID. If you want to follow me on Insta, you can follow me, right? So now let's start. So this is question number 4c. Here you see, so that the space-time interval in an is an invariant under Lorentz transformation. I have already made a video on this topic where I have already proved this. Okay, so I have written in the description box 4c answer, then I have provided a link of that video. Then just do click that link and you're gonna get your answer. Okay, so now next question is, write down the 4d, write down the Lorentz transformation equations in matrix form. Okay, so how to write the Lorentz transformation equations in matrix form? Let me show you. So first let us consider two frames, okay, inertial frames, and these two are S and S dash. S dash is moving with velocity v along x-axis with respect to S, relative to S. Okay, and this is an event, and its coordinate is x comma y comma z comma t in the frame S, and in the frame S dash, its coordinate should be x dash, y dash, z dash and t dash. Okay, let me consider that way. So let me write what I have considered here. So these are two inertial frames, S and S dash. Frame S dash is moving with in x direction relative to S with velocity v. Okay, coordinates of event E in S and S dash frames respectively are this. Okay, these are the coordinates, right? Now according to Lorentz transformation, what were the Lorentz transformation equation? So as it is moving along x-axis, so x dash is equal to gamma into x minus v into t, and y remains y dash. Y dash remains y because it is moving only in x direction, right? Z remains z, z dash remains z, and t dash is equal to gamma t minus xb by c square. And let me tell you one more thing. Here gamma is equal to, just wait, here gamma is equal to, so what do you mean by gamma? 1 by root over 1 minus v square by c square. This is the value of gamma, right? So now let me go to the next slide and let me copy these equations, and let me go to the next slide. I'm going to show you how to write this in matrix form. Okay, so in matrix form, so these equations can be written in this way. So let me show that x dash is equal to, we have got this one, and y dash, z dash, y dash and z dash remains unchanged. Okay, they remain unchanged because the frame is moving in x direction. T dash is this, right? So you see, we can write this first equation in this form. X dash is equal to gamma x, then minus gamma into v into t, then we can write 0 into y and 0 into z. Okay, we can write that way. Similarly, this equation can be written this way: 0 into x, as there is no x. Okay, 0 into 1 into y, because y dash is equal to y. So we can write here we have only y, right? So that's why we can write 1 into y and 0 into z here. Okay, so then similarly in case of time there will be 0 into t as well. And in this equation what we can do, we can write in this form, right? Hope you have understood this. Now t dash is equal to, if you multiply this gamma, then you're gonna get this, right? So now here you can see, if we multiply c on both sides, so just wait, let me write this way. First let me write the term consisting x first, okay, then 0 into y, 0 into z, then let me write the term consisting t, okay, gamma into t. So now let's multiply c on both sides, and doing so what we have got this, right? Okay, so now you see we can write the matrix now. That's how we can write. So what we have done here, now you see. So first you see, so this first row, how I have written this. So there is x. So we know that when we multiply matrix, then we multiply column with rows, right? That's how we do. So that's why here you see y, x, y, z and c into t. That's why what we have done here, you see, so coefficient of x is gamma, this is written here. Then coefficient of y should be written, which is 0 here, this is 0, and coefficient of z is written here, it is z now, next term is, so coefficient of z is also 0. Then we have written the coefficient of c into t, that is here you see. So here you see c into t, coefficient of c into t from this equation, here you see this is the coefficient of t here, you see, minus minus gamma into v, this is the coefficient of t. Now let me write this term here, just minus gamma v into t. So here we have ct, right? Here we have ct, just wait, let me explain properly. Here you can see this is ct, so we can multiply c here and then we can divide. So the coefficient that we have to take is minus gamma v by c. That's why I have put here minus gamma v by c. So hope you have understood this. So similarly, just wait, let me clean these things, just give me a second. Okay, so here you can see then next row how we have written this one. So again x, y, z, ct. So again first write the coefficient of x from the next equation, which is 0, then coefficient of y, which is 1, right? Then again 0, 0, here 0, 0. Okay, so similarly third row from this third equation, right? Third row from this third equation. So here you see first coefficient of x, which is 0, coefficient of y, which is also 0, right? 0, 0, then coefficient of z is 1 here, right? And coefficient of t is again 0, right? So that's how we have written here. Then similarly then c into t. So now let's take this equation, last one. Okay, first coefficient of x, here you see as coefficient of in this third row, as here you see coefficient of t is 0, so we can write coefficient of ct is also 0, right? 0 into ct, 0 into t, both gonna be equal to 0, right? So that's why it's 0. That's simple, right? So hope you have understood that. So now for this last row we have to take the last equation. Here you see first coefficient of x, So here coefficient of x is this one, minus gamma v by c. So that's why I have written here minus gamma v by c. Then coefficient of y, here it is 0. Then coefficient of z, that is 0. Then coefficient of c into t, here coefficient of ct, this term you can say last one, c gamma t, that means gamma ct, here gamma. So this is, so here you see, okay, I forgot to write the c here actually, this c should be written here also. And this is the Lorentz transformation, matrix form of Lorentz transformation. Okay, that's how we can write the Lorentz transformation equations in matrix form. So hope you have understood this. And in different books it may be written different ways. Sometimes this ct dash is written first, in some books ct may be written first. Okay, so then this matrix will be also changed according to that order. Okay, so let me write that way also. Let me show you that. First let me clean these things. Just wait, you can just cut off these things. Okay, right, just wait, let me keep them here. Just let me write the Lorentz transformation equations here. So this transformation can be written in this way also: ct dash x dash y dash z dash, this is the first column matrix, is equal to, then ct x y z. Okay, or you can write this way. First you can write this way also, gamma minus gamma v by c, 0 0, then minus gamma v by c, then gamma 0 0, then 0 0 1 0, then 0 0 0 1, then you can write here ct x y z. Okay, so this equation can be written in this form as well. Okay, don't be confused. In some other books this may be written in this form as well, as this way also, depending on the order of terms how you have taken in these equations. So that's then you're gonna get in different order, right? So now let's answer to the next question. So our next question is, so there is another question 4D or, right? So there are two questions in 4D. Okay, either you need to solve this one or this one. Is it possible for an external force to be acting on a system and relativistic momentum to be conserved? Explain. Okay, so here you see I'm not gonna explain each and every answer here. Okay, because I have not enough time. I have to complete many papers before the exam. Okay, so let me give you the answer of this question or. Okay, so answer to question number 4D or. Okay, 4D or. So here is the explanation of question 4D or. Okay, so take the screenshot of this question. Okay, this question. So this is the answer. Take the screenshot. Okay. So now let me answer to the next question. This is the answer to question number 4. First take the screenshot. I have more pages. So next page is this one, and then this one. Take the screenshot. Okay. Then we have this page. Then take this diagram. Then this one. This is the last page. Sorry, this is the last page. This is the previous of the last page. This is the last page, right? So let me show you again in order. So this is the just wait. This is the first, second page. Sorry, second page, and this is the third page, fourth page, this is fifth, sixth, this is the seventh, that means the last page. Okay, so hope you have taken the screenshot. So now let me give you the idea of this diagram. Okay, now we know that Minkowski space that we are going to discuss about. Minkowski space is a four-dimensional space. If we consider only two dimensions, here you see this is x, and this axis is suppose c into t. Okay, this is not y-axis, right? Now you see interval between any two events in this case will be given by this equation. If you ignore the y-z axis, and then that interval will be given by, you know, here del x square minus c square t square. So that interval is suppose del s square. Let us suppose that. Okay, so it is the equation of hyperbola like this, and when this del s equal to 0, then we're gonna get this kind of line, right? Okay, like this, right? And depending on which one is greater, this hyperbola may be upward, may be downward. Okay, so depending on different conditions. And now you see, and if you consider this in 3 dimensions, this is going to be hyperaboloid. This kind of surface you're going to get if you convert it into 3D. So you're going to get this diagram, right? So now you see, let me clean this now, just wait. Sorry. Now what we have done in this explanation, we have considered that the two events that we have considered, two events E1 and E2. Okay, one event is taking place is at the origin, suppose. Okay, one event is at the origin, U1 is at suppose 0, 0, 0, right? We have considered that way, right, in this case. So now you see, so let me go to this. Okay, so if we consider that these two events, these are the coordinates in two frame of inertial frames, then not two inertial frames, same inertial frames. These are the two events in the same inertial frames. These are the coordinates, and their interval between the two events is given by this equation, right? And now you see, if we consider that one event is at origin, right, at origin, then this equation will be given by this, right? Okay, now we define various world regions as shown in the figure. So as I have taken this one from book, where the figure number is written in this way, that's why it is written 14.3, but you can just instead of writing this, you can write in the given figure. So as shown in the figure, as shown in the figure, you can simply write that way. Okay, as shown in the figure. Okay, so region A, where s square is greater than 0. So let me show you the region here. This region A is the where s square is greater than 0, and region B, where s square is less than 0. Okay, and here you see s is equal to 0. Seat C means this one. Here you see, this is the seat C, this one, and here also s is equal to 0. Okay, these two are not lines now, these are sheets, okay, in this 3 dimension, in the 4-dimensional case as well. So now the sheet C, which divides the Minkowski world into the region A and B given by these equations, okay, S square is equal to 0 and x square plus y square plus z square is equal to c square t. So when this s square will be equal to 0, from this equation you can write this, right? You can write this, and this is represented by r, so simply they're writing this way: r square is equal to ct square, that's why r is equal to c in t, right? So this is equation number 7 we have taken, right? So hope you have understood this. And now you see, in case of 3 dimensions, x square plus y square is equal to z square, right? If you don't consider the dimension of time, then you're gonna get this, right? Now you see here, so I don't want to explain all the things in details here, so whatever needed to be explained all are written in the in this pages. I hope you have taken the screenshot. So let's move on to next question, because I don't want to waste time, because I have many papers to solve, okay? Later on I'm gonna make another separate video to explain only this topic, okay? So our next question is 4F. So here is the answer to this question: explain the simultaneity length construction time dilation with the help of space-time diagram. So here is the answer. This is the first page of this answer, and this is the next page. So this is this diagram which was incompleted. Here it is completed. Then this is the length contraction from this diagram, okay? Then time dilation, take the screenshot, okay? And this is the last page, I think. Sorry, one more page is there. This is the last page, okay? So this is 4F. Now what is the next question? Next question is 4G. Discuss the physical conditions of space-like and time-like intervals, okay? Let me give you the answers directly. So here is the answer. Take the screenshot for question number 4G, right? 4G. Take the screenshot. Okay. Take the screenshot of this page also. And now you see, let me mention one more thing. So here it is equation number 15. It is not necessary that you should write 15, okay? You can write 1, 2, 3, because in the book from where I have taken these answers, because there were more equations before this topic was started, so they have continued from there. So that's why you can give the question number as you want, 1, 2, 3, 4, something like that. So you can start from 1, okay? So then if you do so, then you have to change the equation number if this equation number is mentioned later. If it is mentioned somewhere, then you have to change that according to your numbering, okay? So let me show you from the first page. This is the first page, okay? This is the first page, and second, this is third. Take the screenshot. Fourth, fifth, okay? That's the answer. So our next question is this 4H. We need to prove this relation here. Actually, I have already made a video on this topic, so I have provided the link in the description box. I have written question number 4H answer, then I have provided the link there, okay? Go through and watch that. The remaining questions will be solved in the next video, okay? So stay connected. Thank you for watching. See you in the next video, okay?